have Harper.
You need Tom's.
Okie doke. So, yesterday we did determinants with 2x2s. Today we're going to do a 3x3.
That sounds exciting.
It's the same process, you just do it 3 times for one answer.
Oh no.
Easy peasy.
3 threes for one.
It's going to be easy peasy, okay? So, but what I want to first talk about and look at is, remember, we have in the 3x3, we've got A11, A12, and so the position of each of them goes by row and then column, right? Remember that? So, for instance, this one here tells me that if I said, hey, what's A33? Well, that's row 3, column 3. Remember that part? Okay, so the definition of a 3x3 determinant is you take the very first position and you multiply it by a determinant of this bottom half. And I'm going to show you how to do that here in a minute. And then you subtract the second one multiplied by a determinant, and then you add the third one multiplied by a determinant, okay? It looks super confusing right this second, okay? Just deep breath. It's going to be very fine, all right? It's all good, okay? And the 2x2 determinants, when you have these things, they're called the minors. Okay? And a minor is found by choosing an element of the determinant and crossing off the rows and the columns that contain it. Okay? So, if I want the minor of A11, okay, I cross off the row, and then I cross off the column. What am I left with? I'm left with my normal determinant of A22, A23, A32, and A33. Okay? But you have to do, like I said, you have to do it 3 times, okay? But let's look at the pattern of how we get this. So if I have A11, I cancel that out, okay? And then I'm using A21, and I cancel those row out, and I get 12, 13, 32, and 33. Are you with me so far? And then you add the last one, and you cancel them out. That's the true definition of it. Okay? Are you all with me so far? All right, flip over, and we'll do one. Okay, now, it's called expanding down the first column. All right, now the rule said I take the first one, subtract the second one, add the first one. So it's like my signs are going to be plus, minus, plus. Okay? I lost you on that?
So we're taking, so there's A11 plus.
Hold on. All right, so my first one is a -2, and I'm going to multiply it by my minor, which would be 1, -4, -1, and 5. Are you with me on that? And actually, I'm sorry, we should have written it down here. Because we have to do it 4 times, or 3 times. I'm not talking well today. Okay, so that was my first. Now I'm going to do the second one in the column. And so I cross off the first column, and I cross off the row. And what's left? I have 0, 5, -1, and 5. Okay? And then for my last one, I cross off the last row in the column. I use the 2, and what do I have left? I have 0, 5, 1, and -4. Okay, good so far? Everybody's seeing where I'm getting these numbers at then? Yeah? Okay, so to find my determinant of this, 1 times 5 minus -1 times -4. So I'm going to have 5 minus 4. Would you agree with me on that?
Yeah.
Okay, so that means that my determinant's 1, so for this green first one, I'm going to have -2 times 1. Yeah? And then you do it for the next one. And this is where that plus minus plus comes in, because now I have to subtract, and then the last one, I'm going to add. Yo.
So the first one always has to be positive?
Well, you're adding. It's not that it's always positive. You don't change the sign, because this was a -2, so it just stays as a -2.
So shouldn't it just be minus plus? It's even blank. Minus blank plus. Like, I don't know, it is a plus, minus plus. Like, you're not doing anything with the first one. It's just there.
Correct. You'll when we get down here, it'll make more sense. Okay, so determinant of the second one, 0 times 5 is 0. Minus -1 times 5 is going to give me a positive 5. So I have -3 times 5. Because you take the number outside. Oh. Are you with me? Because I figured, because anything plus 0 is going to just be the same. All right, last one. 0 times -4 is 0.
Why is it?
It shouldn't be negative, huh?
Yeah, that's what I was confused about.
Oh, negative. Makes it positive.
What?
It's not negative.
What are you talking about? Where?
0 plus 5. It'd be 0 minus
0
5.
plus
No, I mean, 'cause it's
0
5
plus,
times -1.
because it would technically would be 0 minus -5.
Yeah, okay.
So 2 negatives made a positive.
And then why is the 3? Is that -3?
Mm-hmm.
Okay, all right, got it, cool.
All right. Okay, so 0 times -4 is 0. 1 times 5 is 5. So my determinant is going to be -5. So it's going to be plus 2 times -5. Okay, are we good?
So it's -2 minus 15.
So now you take, right, so the determinant of the whole thing's going to be -2 minus 15 minus 10, which will give me negative 27. Good? Make sense? Okay, now to get back to Sarah's comment about I don't understand the plus thing. This is called expansion by the minors, okay? We did the very first column, except you can expand along any row or column, okay? The only difference is if you pick a different row or a different column, you have to use that sign for the positions. So if I took the second position, then it would be, instead of the plus negative or plus minus plus, I would do minus plus minus. Okay? So I always put the pluses in there because it helps me remember the pattern. Does that make more sense, Sarah? Mm-hmm. Okay? So, for instance, on the next example, if we're going to expand across the second row, okay, that means I'm going to go across here, which means I need to use those symbols. So that means now I'm going to have, it's going to be a negative, a positive, and then a negative. Does that make sense? Okay, so now my first one is going to be the 6. And if I cross out my rows and columns, I'm left with 2, negative 2, 3, and 4. Good? Am I going too fast? Now the next one I'm going to go is in the middle, cross out my row, cross out my column, and I have 0 on the outside, and 3, 2, negative 2, 4. And last, I'm going to hit at the last column, and I get 3, 2, 2, 3. What do you think? Looking at what we've just done here to set up, why would I choose to pick the second row?
Because then you only have to do the first one.
Yeah, because what is anything times 0?
0.
So it's like it just goes away. I don't even have to do a calculation. What's 0 times that? 0. So the only one I really truly have to do is 2 times 2, which is 4, or 8. 2 times 4, which is 8, minus a negative 6. And so my determinant's going to be negative, what's 16? 14 times 6. 84? So sometimes looking at what the situation is, looking at the rows that you have in there, a lot of times it's a lot easier to pick that particular row. Okay? All right, we have some practice problems. And we're going to use this sheet for what?
I feel dumb, but where did you get the 14 from? I was writing.
Because you're fine. 2 times 4 is 8. And then 2 times 3 is negative 6. And so the 2 negatives made it a positive.
Oh, so are you?
Because I'm subtracting, just like my regular 2 by 2 determinant yesterday.
Oh, okay. Okay.
Okay, so,
Yeah.
Good.
For some reason in my head, I was thinking that was like -8 + 6.
gotcha. Okay. All right, so here's what the thought is, and we'll do a couple more of these once I get these handed out to get to you guys. But my thought is that we'll do like the first 8, just the determinants today, and then tomorrow we'll apply the Kramer's rule to it, kind of thing. Does that sound like a deal? All right, so